Hello and welcome to another one of these ADD videos. Today we're going to take a second look at rotational kinematics, more specifically the rotation of rigid bodies. So what is a rigid body? A rigid body is any object that has a definite and unchanging size and shape. All right? And what happens is they usually rotate about a fixed axis, creating some angles. And whenever there's a distance traveled, that distance, that curvature right there, is called the arc length. And this is just a review of pre-cal or trig. Here we know that the arc length is equal to the radius times theta, so theta would be the arc length over the radius. If you've forgotten any of your basics of trig, like how to convert from degrees to radians and all that, please go to the pre-calculus section and just take a few minutes to review. All right? So the most basic thing that can be asked from you, if we were looking at some rigid point, whatever it is, let's just say it's a spherical point that goes from here to here, and we want to know what the angular displacement of that rigid body is. Well, angular displacement, anytime it's delta theta, delta anything is final minus initial, so you would take theta 2 minus theta 1. If you were asked to do the average angular velocity, you would just take the angular displacement over the time difference it took for that angular displacement. So the T2 is the time at the second theta, the T1 is the time at the first theta. If they ask you for instantaneous angular velocity, there's one of two ways you can do it. You can either do the limit as the delta t approaches 0. Sorry, that should be a delta t right there. All right, good enough. Anyway, so limit as delta t approaches 0 of the ratio of the angular displacement to the change in time. So d theta over dt, delta theta over delta t. Now, the derivative version of this is much easier. If you're given a theta equation and you take the derivative of it, then you can get the instantaneous angular velocity. All right? And most of the times when I'm solving a problem, I will do the derivative, whether it's instantaneous angular velocity or the same principles arise for acceleration. So I would take the derivative of the angular velocity equation with respect to time to get the instantaneous angular acceleration, alpha, or the average angular acceleration would just be the change in the angular velocities over the change in time. All right? So you can see it's always the previous level change over the change in time whenever we're looking at average, whether it's velocity, that would be the change in the angle, or whether it's acceleration, would be the change in the angular velocity. All right? So if I wanted, again, instantaneous acceleration, then I would just take the derivative, okay, of the omega with respect to time. So d omega dt for instantaneous alpha. And that's basically it for the concept here. Make sure you check out some of the videos for the examples. You'll see that these problems, again, aren't too bad if you just do a few of them. All right? It gets a little bit more complex when we start talking about multiple rotations, and we'll deal with that later. I hope I've clarified any confusion or doubts that you might have, enough so that you would at least try some of these problems. Practice, practice, practice is always the key. Thank you and have a nice day.